In this lecture, we are going to discuss about ARM processor families. Now, this is an entirely different kind of microcontroller architecture we are going to study. It is quite different from the ones that we have previously looked upon, like 8051, MSP 430, Atmega 8, 16, 32. Alright. So, what is ARM exactly? Or ARM microcontroller. So ARM is basically it's a company that goes by the name ARM Holdings or ARM Holdings, which develops processors, SoCs, system on chips, softwares, etc. So this company was founded as an advanced RISC machines in 1990 as RISC is the main CPU design strategy implemented in its processors. So RISC is reduced instruction set computing. So ARM utilizes this RISC set in the design of its processors. Now, another important feature to note about this ARM company is it actually does not manufacture processors like the companies Intel, AMD, or your Atmega, right? Freescale, Hitachi, etc. So all these companies they manufacture processors or they manufacture microcontroller ICs, but ARM doesn't do that, right? It does not manufacture any processor controller or any other semiconductor devices. But what it does is it licenses the semiconductor cores as IP, that is intellectual property, to the other semiconductor companies like Atmel, Philips, Samsung, etc. So it is licensing its semiconductor cores. So if you have noticed or if you have come across any kind of board or device that uses ARM microprocessors or controllers, then that device is manufactured by some other company. But yes, it uses an ARM based processor. Alright. So that is the semiconductor core that ARM is allowing other companies to use as intellectual property, right? The important IPs of ARM include its low power, low cost, high efficiency, RISC based microprocessors and SoCs as well as some other peripherals. So apart from the processors and IP cores, ARM also provides comprehensive software development tools like Keel and DS5 for developing complete systems based on ARM microcontrollers and systems on chips. So you must be familiar with Keel. We have used the software in programming 8051 microcontrollers as well. So actually it is developed by the ARM company only. So not only it develops processors and semiconductor cores, but it also develops software development tools. Now remember, development of processors does not mean that it's manufacturing it. Only uh, licenses its semiconductor cores, okay, hardware wise. Now let us look at some of the basic features of ARM processors. We will look at these ARM processors in detail, the kind of processors that ARM company actually develops in next lecture. So ARM processors, as we have seen this already, they are based on RISC, that is a reduced instruction set computing architecture. But obviously based on the requirements of the embedded systems or the product that you are making, some amendments to the RISC architecture can be made. ARM processors follow load and store type of architecture, where the data processing is performed only on the contents of registers rather than directly on the memory. So this is one important difference between the previous microcontrollers that we have studied, in which we could also perform operations on the memory that is integrated with the microcontroller, or whether it is an external memory. But in ARM case, we can only do the operations and processes on registers. The instructions for data processing on registers are different from that which access the memory, unlike other microcontrollers. The instruction set of ARM is uniform and fixed in length. 32-bit ARM processors have two instruction sets, that is a general 32-bit ARM instruction set and a 16-bit thumb instruction set. तो दो आपके instruction sets available हैं. One is 32-bit ARM instruction set and a 16-bit thumb instruction set. ARM supports multiple stages of pipeline. This is very important to speed up the flow of instructions. In a simple three-stage pipeline, the instructions follow the conventional three stages, that is fetch, decode and execute. Another important advantage and feature of ARM processors is that they have a wide range of clock frequency which can range from 1 megahertz to few gigahertz. So this is a very important point which is not present in usually all modern microcontrollers. They cannot even touch a few hundred megahertz, leave alone gigahertz. Alright. ARM processors have built-in hardware for debugging and they support enhanced instructions for digital signal processing operations. So this is also very important. DSP based operations के लिए ARM processors and ARM architecture is way ahead as compared to your conventional microcontrollers and processors. So these are some of the families in ARM. जैसे आपका different families होती हैं किसी भी माइक्रो प्रोसेसर में या कंट्रोलर में, सेम वे में ARM की भी कुछ डिफरेंट फैमिलीज हैं based on a certain type of architecture. So these are some of the families. For example, ARM 7 TDMI, which is based on ARM version 40 architecture. Then you have ARM 9E, that is based on ARM V5TE architecture. Right? Same way में you can see Cortex M. Cortex M is a very popular and widely used ARM processor in a variety of devices. Even आपका जो Raspberry Pi computing system है, that also uses Cortex M based processor. So it is based on ARM version 7M architecture. Similarly, you can see Cortex R, Cortex A, Cortex A 64-bit. They are based on ARM version 7R, ARM version 7A and ARM version 8A architectures respectively.